Imagine a night sky untouched by telescopes. Just you, the stars, and the vast darkness stretching above. Yet, thousands of years ago, humans were already exploring the cosmos, navigating oceans, predicting seasons, and recording celestial events, all without modern tools. Tonight, we journey through time to uncover how humans explored the stars before the invention of the telescope. Long before Galileo, Copernicus, or Newton, humans gazed at the heavens with curiosity, wonder, and necessity. The night sky was more than decoration. It was a map, a calendar, a compass, and a source of stories. Through patient observation and careful reasoning, early humans began to understand the cosmos, shaping civilizations, guiding travelers, and laying the foundation for modern astronomy. The dawn of observation. Prehistoric humans had no instruments, yet they observed the patterns of the stars, the moon, and the sun. Early structures such as Göbekli Tepe in Turkey and Stonehenge in England show that humans tracked celestial events with remarkable accuracy. Stone alignments marked solstices and equinoxes, helping communities organize agriculture and religious rituals. These massive constructions were the first observatories, revealing the human desire to measure and understand time and space. Even before writing, people noticed cycles, the moon's phases, the sun's rising and setting, and the recurring paths of stars. Observing these patterns wasn't mere curiosity, it was survival. Early humans relied on the sky to know when a plant crops, when to harvest, and when to migrate. Without telescopes, they still developed profound knowledge of the cosmos, carefully recording events over generations. Civilizations and their sky knowledge. Across the globe, civilizations turned observation into science. The Babylonians recorded the motions of planets, eclipses, and star positions for centuries, predicting celestial events with astonishing accuracy. Egyptians observed the heliacal rising of Sirius to predict the Nile's annual flood, essential for agriculture. In ancient China, astronomers documented comets, novae, and planetary paths, leaving detailed records that would influence generations. These societies didn't just watch, they created tools to aid observation. The astrolabe allowed astronomers to measure the altitude of stars above the horizon, helping navigators determine latitude. The armillary sphere modeled the heavens, giving scholars a way to visualize the movement of celestial bodies. Such instruments bridged human observation and mathematical reasoning, showing that astronomy thrived even before the telescope. Constellations as maps and stories. Stars were organized into constellations, which served practical, cultural, and navigational purposes. Greek mythology turned the night sky into a narrative canvas, with Orion, Andromeda, and Cassiopeia telling stories while also marking the seasons. Polynesian navigators memorized star paths to cross vast oceans, using celestial knowledge as living maps. The sky was both a practical guide for survival and a repository for culture, history, and memory. Navigation and exploration. Long before the telescope, humans navigated the seas by stars. Polaris, the North Star, remained fixed in the northern sky, helping sailors maintain a steady course. In the southern hemisphere, the Southern Cross guided explorers across the oceans. Arab, Polynesian, and Viking navigators memorized star patterns and used them alongside the sun, wind, waves, and wildlife to travel thousands of miles. This knowledge allowed trade, exploration, and cultural exchange long before telescopes existed. Predicting celestial events. Observation wasn't just for navigation, it was for prediction. Babylonian astronomers calculated lunar eclipses, planetary positions, and conjunctions. Chinese astronomers meticulously documented comets, meteors, and novae, sometimes linking them to historical events or omens. The Maya developed complex calendars based on solar, lunar, and planetary cycles. Even without telescopes, these societies understood patterns in the sky and could anticipate major events, shaping culture, agriculture, and religion. Mathematics and astronomy. Greek thinkers like Pythagoras, Aristotle, and Ptolemy applied geometry and mathematics to celestial observations. Ptolemy's Almagest described a geocentric universe, predicting planetary positions with remarkable accuracy. While we now know his model was incorrect, it represents centuries of accumulated observation and reasoning. Even without magnification, early astronomers combined careful watching with logical deduction to understand the heavens. Calendars and timekeeping. Tracking celestial movements allowed civilizations to create calendars and organize time. The moon's phases provided a natural measure, while solar cycles defined years. Ancient Egyptians and Mayans developed sophisticated calendars, linking celestial events to agriculture and ritual. Stars, sun, and moon together became humanity's first clocks, helping societies coordinate labor, ceremonies, and survival strategies. Mythology as knowledge storage. Stories encoded astronomical knowledge. The Pleiades cluster appears in Greek, Native American, and Aboriginal Australian mythology, often marking seasonal changes. Legends about Orion, Sirius, and the Milky Way preserved observation patterns across generations. Before telescopes, myth and science intertwined, helping humans remember the sky's complexities. Global astronomical knowledge. From the Americas to Asia, Africa to the Pacific, civilizations observed and interpreted the sky differently, yet each contributed to humanity's understanding of the stars. Mayans tracked Venus and solar eclipses with precision. Polynesians memorized stellar paths for ocean navigation. Babylonians created mathematical models, and Chinese astronomers charted planetary motion. Collectively, these efforts created a foundation for the scientific revolution in telescopic astronomy, laying the groundwork for telescopes. When Galileo turned his telescope toward Jupiter, he was not starting from zero. He built on thousands of years of naked-eye observation, accumulated records, and mathematical models. Telescopes amplified human knowledge. They did not create it. The patient, meticulous work of pre-telescopic astronomers paved the way for discoveries that reshaped our understanding of the universe. The stars have always inspired wonder, curiosity, and discovery. Long before telescopes, humans explored the cosmos with nothing but their eyes, instruments like astrolabes, and minds capable of incredible observation. They mapped the heavens, predicted eclipses, navigated oceans, and structured societies around celestial patterns. The next time you look at the night sky, remember that humanity's journey to the stars began thousands of years before Galileo, proving that curiosity and ingenuity are timeless. The night sky was humanity's first laboratory, and exploration began with observation, imagination, and patience. From tracking Sirius to mapping Venus, pre-telescopic astronomers taught us that the universe can be explored even without sophisticated tools, and that the desire to understand the cosmos is one of the most fundamental aspects of being human.